Hi all, we're back for the third installment of sequences. Today we're going to talk about geometric sequences. Again, we're going to have about 2 videos to break it up a little bit. Today's lesson, as I already said, is about geometric sequences. Our essential question for today is, how do I write a recursive and explicit formula for a geometric sequence? Remember last time we did arithmetic sequences. Now we're moving on to geometric sequences. Just to reiterate, a geometric sequence is a sequence of numbers where each term after the first is found by multiplying the previous by the same answer. So like this one, how do I get from one term to the next term? Well, I'm multiplying by -3, right? Multiply by -3, multiply by -3. Okay, that's how I know it's geometric versus arithmetic. Remember, arithmetic is adding and subtracting, and geometric is multiplying. So remember, we're multiplying today. Okay, so let's go into the first little set of problems that we're going to work on. And it's kind of just a review from last time and the time before. I want you to tell me whether the sequence is arithmetic or geometric, and then find the next 2 terms. That's it. So is it arithmetic? Is it geometric? What's the next 2 terms? So how do I find out which one it is? Well, I'm going to look at the 2 terms here. I'm looking at, how do I get from 4 to 8? Well, I could either add 4 or I can multiply by 2. I have 2 choices there on that one. So I can either add 2 or I can multiply by, oh my Lanta, let me erase that and rewrite it. Let's try that again. So I can either add 4 or I can multiply by 2. So I'm just going to check the next one and see which one's right, the next combination. So how do I get from 8 to 12? Well, is 8 times 2 12? No. So I'm not multiplying by 2. Is 8 plus 4 12? Yeah. So I'm adding by 4. So it's add 4. And if I'm adding the same number every time, what type of sequence is that? It's arithmetic. Good. Arithmetic. Awesome. And then it says, what are the next 2 terms? So 20 plus 4 would be 24, and 24 plus 4 would be 28, and ... And that's it. That's all we're going to do for this. Let's go ahead and do the next one, and let's see what we get. So again, I have 2 choices here from 2 to 6. I can add 3, or I can multiply by, add 3. I am doing really good with my, obviously I'm doing really good today, you guys. Whew. Okay, let's try this again. I can add 4. 2 plus 6 is 4. 2 plus 4 is 6. Whew. Or I can multiply by 3. I think I'm thinking ahead too much. So which one is the next one? So how do I get from 6 to 18? Well, obviously 6 plus 4 is not 18, so it's not adding. Is 6 times 3 18? Yep, so I'm multiplying by 3. Multiply by 3. Oops, make that look like a multiplication sign. So that means this is geometric. And I'm just going to tell you, I'm going to pause for a moment. Notice I've made a few mistakes. I want you to know that I make mistakes. I am not going to go back and edit this out. I'm not going to start the video over. You guys are just going to have to deal with my mistakes as I go along. I make mistakes. Math teachers make mistakes. As long as you fix them and move on, I'm good with that. I'm okay. Mistakes help you learn. So here we go. If I make a mistake though and you catch me and I haven't caught myself, hey, send me an email. I'm good with that. I'll be like, oh, good job. Okay. Unfortunately, because this is a credit recovery class, I can't give you extra credit. But if you were in my class and you caught a mistake in my video and you catch me, yeah, I give my kids extra credit. So anyways, here we go. Next 2 terms. So I'm going to take 162 and I'm going to multiply it by 3. Grab your calculator. 162 times 3 is 486. And I'm going to take 486, I'm going to multiply by 3. And I should get 1,458, ... And we only need to find 2 terms, so I'm good there. Okay, not too bad. Not too bad. Okay, so now we're gonna go to the next one, and oh, I'm going down. Here we go. So how do I get from 128 to 64? Or 64 to 32, and 32 to 16, and 16 to 8? Well, the difference between those two numbers is definitely getting, it was pretty big and it's getting smaller, so I'm not adding the same number. So what I can do is I can take my calculator, right? And I can go 128 divided by 64. Nope, wrong way. 64 divided by 128. Woo! 128 divided by 64. And I still wrote it the wrong way. Okay. 64 divided by 128. 128. So I want to take this number and divide it by, I want to take this number and divide it by this one. So this one divided by this one, and this one divided by that one, and this one, 16 divided by 32, 8 divided by 6. Well, if I put it in my calculator, I'm going to get 0.5. Okay, and so we can think of 0.5 as 0.5, or we know that it is also 1/2, right? I'm taking half of it. So what is half of, oh, what type of sequence is that first? Good, it's geometric. And then half of 8 is 4, good. And half of 4 is 2, great. And I'm just gonna continue this one just for a second. What's half of 2? 1, great. And what's half of 1? A half. And then I go into fractions, right? Now I can write it as decimals, or I can write it as fractions. Sometimes it's easier as fractions, because then sometimes our decimals start becoming repeating decimals, and those aren't so pretty to write down. That's why I like writing them as fractions if you can. I just wanted to throw that out at you. So good job, you guys. So again, we are going to talk about graphing the sequence. Even though we may not do any graphing this particular time, I just want to show you that there is a difference between what the graphs look like. Remember, a linear graph was a straight line. All the points were in, if I connected the points, they would be in a straight line. Well, we want to see what a geometric sequence looks like. So here's our definition. To graph a geometric sequence, create a table. So we're going to do it the same way. We're going to create a table where the terms position in the sequence is the x values. So its position is the x values. That means the sequence itself are my y values. Okay, so I'm going to go ahead and write those in as my y values. So I've got 1, -3, 9, -27, 81, -243, ... Okay, so this one is in position number 1 in the sequence. -3 is position number 2. 9 is position number 3, or term number 3. -27 is term number 4. 81 is term number 5. I can count it, right? 1, 2, 3, 4, 5, 6. And those become my x values, ... Okay? And then you put them on a graph. And we're going to practice that right this instant. We're going to practice graphing right this instant. Okay? So, oops, here we go. I'm going to make this a little bigger. Okay. So I want to make a table. It says create a table. So I'm going to create a table. And I have my x value and my y value. Okay. And then I have 1, 2, 3, 4, 5. I have 6 terms here. So term number 1 is 1/4. Term number 2 is 1/2. Term number 3 is 1. Term number 4 is 2. Term number 5 is 4. 4, and term number 6 is 8. Beautiful. And now I'm going to graph that on my graph. My x values are going by 1. 1, 2, 3, 4, 5, 6. And my y values, I think I can go by 1 also. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Awesome. On this one I can. So now I'm just going to graph it. 1 and 1/4, so it's right there. 2 and 1/2. 3 and 1. 4 and 2. 5 and 4. And 6 and 8. Notice my points do not form a straight line this time. It's more curved, so it's a curve this time. Okay, so now we're going to do one more graph and see what this one looks like. So we're going to do our table, and I've got 1, 2, 3, 4. I only have 5 terms this time. That's good, because I don't have a lot of room left. So term 1 is 27, term 2 is 9, term 3 is 3, term 4 is 1, and term 5 is 1/3. Okay, so I'm again on my x values, I'm just going to go by ones. 1, 2, 3, 4, 5. But on my y values, I have to go up to 27, so I think I'm going to go by 3s. So I've got 3, 6, 9, 12, 15, 18, 21, 24, 27. Now I can do that as long as I go, the increments are even, each interval is even, and I choose one that works, right? I went by 3s and it gives me 27, and I can get to 1 and 1/3. I can get all those in there. So it works for me. And my starting one is the same increment. So this increment right here is still 3 and 3 and 3. Notice there's 3 all the way up. It's the same increment every single time. So that means I don't always have to count by ones. I just wanted to throw that out at you. Boy, I'm saying that a lot today. So sorry. So 1, 27, 2, 9, 3, 3, 4, 1, and 5 1/3. Should be way down there. Okay, so there again, not a straight line. Okay, good job, you guys. So you're going to do a few problems just like last time and the time before, and then we'll come back with the second half of the video when we're talking about the recursive and explicit equations for geometric sequence. So we'll see you in a few moments. Thanks. Bye.